Yeah, so here generally, so we have a multiple different types of software can be used for instrumentation.
Injection there.
हाँ, अभी ये software called Excalibur and Trace Finder. So Trace Finder is the updated version of your Excalibur. So this is not a two different software. This is the basic software Excalibur, and the updated package of your Excalibur will be your Trace Finder. Here the advantage in Trace Finder. So generally in the analytical flow, we need to create first. There are multiple methods. Methods means the set of instruction to the instrument. Under what condition the instrument should acquire the data, right? So method to method we require certain parameters like temperature parameters, sample volume, flow, carrier flow, pressure. So these are all the parameters need to be defined to the instrument, under which condition you have to acquire the data and produce the chromatograph. So that is the one type of method called instrument method. Set of parameter for the hardware or instrument to acquire the data, that is called instrument method. We have another method called processing method. Processing method, whatever the raw data we receive, raw data in the sense the chromatogram, so that is completely blank data. We cannot see any information on that. So we have to interpret that scientific data. Scientific data cannot be modified. It is not like our word paragraph. So we can rewrite and do something. But once the scientific data generated, you cannot modify, right? So you cannot add peaks, you cannot delete peaks, whatever, you can't do that. So this is the unique data you need to properly interpret. That is called the data integration or data processing. For that data processing, we have to create one more processing method. The parameter which involved in the instrument methods are different and the processing method are different. Processing method में क्या होता है? Mathematical algorithms होता है. Mathematical algorithm means the integration of the peak width, retention time calculation, or full width of maxima, and there is a area response calculation. This is all about the mathematical expression, right? So we have a different algorithm for that. Using set of algorithms, we can integrate the peak and quantify it. Identification के लिए we have a direct library search. We need not to go for any data integration. That is a means qualitative processing method. Qualitative processing method is different and quantitative processing method is different. क्वालिटेटिव में क्या होता है? सो हम लोगों को कंपोनेंट का इंफॉर्मेशन पता नहीं चलेगा. सो दैट इज द रीजन वी हैव टू जस्ट गिव अ मीन्स जनरल इंस्ट्रक्शन टू द इंस्ट्रूमेंट टू फाइंड आउट द लाइब्रेरी सर्च. बट क्वांटिटेटिव में होता है हमको कंपोनेंट पता है. सो कौन सा कंपोनेंट है, मीन्स व्हाट इज द आरटी रिटेंशन टाइम ऑफ दैट कंपाउंड, व्हाट इज द मासेस ऑफ अ पर्टिकुलर कंपोनेंट. सो एवरीथिंग वी नीड टू डिफाइन इन द प्रोसेसिंग मेथड. देन वी विल गेट द एक्यूरेट data in the processing, and then we need to produce specify the quantification like a level of linearity. So linearity level means linearity will be a kind of graph, and that is a scale for measuring the concentration. To measure any of this we need to have a scale. To measure the length you need to have a millimeter, centimeter, feet and all these things. Measuring the weight you need to have gram, weight and all these things. Measuring the volume you need to have a liter level. So similarly concentration. So to measure the concentration we need to have certain reference scale. So that is called concentration versus area response. Okay, based on that linearity graph we are going to measure the unknown sample quantification based on known concentration area. Okay, anyway that also we will be discussed in the calibration protocol. So that we are going to work on the system, right? So now before going to start our routine analysis, whenever you are working on this GCMS or LCMS, always you have to monitor the status of the mass spectrometer. Okay, so it's similar to that, it is called as a system check, or like your normal pH meter. Whenever you wanted to read some pH of any samples, you are first calibrating the pH meter, feeding the known pH solution, okay, or buffer solution, pH buffer solution. Then if it is given the proper pH, so we directly take it. If not, we calibrate the pH meter to read the proper pH, then we go for unknown sample detection. So similarly here we also have to monitor the system first. Once it is giving a proper data or confirmation, then we can proceed for unknown sample detection. Okay, see here you can see Excalibur. I'll click on this Excalibur software. So this is our software. Before going to Excalibur, you can see TSQ series dashboard. So this is for your MS operation, MS data. TSQ series means TSQ 9610 is for your MS. Similarly, you have for GC and auto sampler. Here you can see. So this is your system configuration. You can see here thermoscientific S2 for Excalibur. This is for your GC, and TSQ series for your MS. Always you must observe the ready to download means instruments are communicating to your software. They are ready for our operations. If there is any error or not properly communicating, you can see some sort of error here, or not ready, or maybe showing some error. Okay, so you have to connect properly. So now we'll go with this here. GC, you can see, you can directly go to direct control. Here you can see the configuration. We have GC, it is connected. Triplex RSH is connected. Front inlet parameter, what is the carrier flow we have to supply to the carrier flow, and the purge flow, split flow, temperature of the inlet. So everything can be defined here. Now column properties. What is the column we have installed on the system? This is the column what we have installed, TG5MS column, right? You can see the column, TG5MS column we have installed, and the dimension of the column. Dimension of the column need to be defined because the column flow, the pressure should be adjusted accordingly. Because the length varies 60 meter, flow pressure will be different, 30 meter, flow pressure will be different. 0.32 and 0.53 flow pressure will be different. So accordingly we have to define the column specification, then column flow automatically it will adjust as per its pressure and temperature. So we have defined the column properties over here, and sometimes so we have certain procedures, the column installation procedure. So because column is consumable, so depends on your type of sample analysis. Sample to sample column may vary, chemistry also may vary. So that we need to change the column and install the column all the time. Yeah. We need to change the column and install the column all the time as per our requirement. So for that column installation, first you have to connect the column from the inlet side, check the column flow, carrier flow, and then check the leak check. Whatever the nut and ferrule you are going to use it for the proper fixture. So sometimes what happens, if the ferrules are not properly fixed or not as per our dimension of the column, there may be a vapor loss or leakage. To check the leakage, you have to perform a leak check. Once you perform the leak check, the other end of the column should be blocked. So the carrier flow achieves some pressure. So for 1 minute or 2 minutes, the column should hold that pressure, whatever the pressure we set, probably 200 kPa. So same pressure should be held for 1 minute or 2 minutes. Then it is confirms that there is no vapor loss, carrier loss. If the pressure is coming down gradually, 200 to 190, 180, 170, like similar to that, somewhere there is a vapor loss. So that gives you the confirmation of that proper fixation of your column. Okay, so that is the confirmation. Then our analysis is going smoothly. If there is any leakage, our quantification also going bad. Sometimes qualitative analysis also not successful. Clear? Then other end of the column you are going to install based on the detector you are going to select. Okay, so the length of the column insertion, everything vary from detector to detector, or if it is MS, we have a measuring tool. Using that measuring tool, you can connect the column in the interface. Okay, next after that, here the temperature as well as your MS transfer line temperature. MS transfer line temperature, where we are defining in the wherever MS parameter can be defined. Here in this case, we have one TSQ dashboard series. Here you have to monitor the instrument condition. See, vacuum, it should be 4 pressure, means vacuum. So the vacuum level should be to the highest maximum limit. Okay, if vacuum is perfect, so then your performance, your analysis going smoother. If vacuum fluctuates, so your interferences and mass accuracy will be varied. Okay, next is your where you can see line pressure and transfer line and ion source temperature. Transfer line temperature is your column extended length of your column. So the intermediate interface is your transfer line temperature. Transfer line temperature should be always either equal of your column temperature, oven temperature, or slightly higher than that temperature, because it should not be condensed. The molecular movement at the same temperature, it should be in a forward direction. If there is any temperature reduction, there sometimes it may go for condensation. So to avoid that condensation, we always give a highest temperature in the transfer line temperature. I think if somebody noticed it, it was discussed in the morning session as well. So sir, he was discussing the transfer line temperature, interface temperature, why do we have to insert? Okay, so that is the importance. So to avoid the condensation of your molecules, right? Then your ion source temperature. Ion source temperature is very important. Yesterday, if I have shown you one animation, in that animation, if you have observed, so there is a temperature cell, coils, that increases the temperature to burn out your molecules, to become the ionization process, to produce us the ions. So the temperature is also very important. So we generally have to give a highest temperature, goes up to 280 degree, 300, 350 degree Celsius. So within that limitations, sometimes we recommend to give high temperature because to avoid the source contamination. Source is also consumable, so that sometimes may go contaminate. So because of the sample matrix impact. Okay. So for that reason, we have to define the sufficient enough temperature, and then the vacuum level, everything is okay. So finally, we have to check the instrument condition using your. Let me just check. Set. Okay. Yeah. So finally, you have to just monitor the air, water and cal gas spectra in GCMS. Air, water, cal gas spectra क्या होता है? Air, water, you know molecular weight of air and water. So what is the molecular weight क्या? Water 18. So air अलग अलग है, no specific. Air में क्या क्या होता है? Oxygen होता है, nitrogen होता है, carbon monoxide होता है. इसीलिए ठीक है. Yeah, so now we'll go with the air water spectra. If I go for a air water spectra, I have to keep the your filament off. Filament off in the sense EI ionization should not happen. In air water spectra, the compound molecular weight as such will be identified. No fragmentation. Okay. So now after that we have one cal gas spectra. So calibration gas, yesterday I discussed on the PFTBA, perfluorotributylamine, right? So that gives us some masses. So I'll just show you with this. See here I have selected the spectra as air, cal gas is off. If I start scan, you can see what are the masses you can see here? 18, 28 nitrogen, 32 oxygen, 40 carbon monoxide. Clear? So air and water, which is showing the clear masses. It means gives the confirmation that system is reading the proper mass for the proper molecule. One confirmation. This is only about the ionization, ion identification, but not about the fragmentation. So let us go with the second experiment. Here I'll take full means calibration gas spectra. I will take the EI ionization here. Okay. So during that EI ionization, what happens? Cal gas module. Within that, so 100 microliter of your PFTBA is loaded. Okay, so that is your analyte for checking the MS performance. So generally what happen in our routine analysis, the molecules are separated in the GC and goes to your mass for the identification purpose. But now our purpose is to just check the MS performance, whether it is functioning its role properly or not. Our intention is not for the separated molecules. Now, just to check the MS performance, we have a preloaded compound, that is PFTBA. It goes directly to your ionization source. Instead of going through your column, it directly goes into your ionization source. Once it reaches the ionization source, the process starts. Ionization with the impact of electron ionization, bombarding with the electrons, hit to the molecule, becomes a molecular ion, then fragmentation with 70 electron volts. Fragments are generated, then goes to the process, acceleration, mass filter and detection. So entire process, whether it is perfectly working or not, what is the output? We need to get the expected masses detection at the specific sensitivity. Then it is working perfectly. Clear? If I start scanning, see MS started its function. Okay. So this spectra gives us the confirmation PFTBA is a molecule which gives this is the spectra. What are the spectra? 69, 100, 131, 219, 219, 264, 414 and 502. So generally we have taken 5 masses as a reference masses.
Yes.
All 5 masses should be visible here. Okay, 69, 1414 and 502. If these all masses are properly visible with the expected intensity, see here you can see peak intensity e to the power of 7. It generally it should be e to the power of 6 and above. 7, 8 hota hai. Okay. So now this gives ion source is generating the proper ions. Fragmentation is also happening properly. Mass filter also filtering, because detection, this is the result of detector, not the ionization. So masses are properly filtering in the mass spectra, mass filter like analyzer, then reach to the detector. Detector giving the proper response as well. Means the function process of the MS is perfect. Once it is confirmed, we can start easily working on the sample analysis. Clear?
These are the compounds. These are the compounds.
This is the compound. This is the compound, not our targeted compound.
Okay.
It is the, see, generally you are going to, same example, you are going to read the pH, correct? So आप unknown sample का pH निकलता है ना, उसके पहले आपको pH buffer डालता है, वो क्या है? वो भी solution, आपका sample जैसा solution ही है, उसका pH मालूम है वो, ठीक है हमको, so उसका set करना है. So similarly here, PFTBA is also a kind of analyte, so it is preloaded in the system to check the system performance. Clear? Why it is selected only PFTBA? Sometimes what happens, PFTBA is a highly stable compound. It will not go degrade, it will not evaporate faster, and more importantly, it covers the maximum molecular weight. So generally what we are working the mass range. So let's start from lower masses to high masses. So up to 600, 650, it's a molecular weight of this PFTBA will be 650. Okay, it covers the entire ranges of masses. So that is the reason this PFTBA is universally used, commonly used in this technology, irrespective of model and vendor. So whether it is from Shimadzu, whether it is from Agilent, Perkin Elmer, Thermo Fisher, whatever the model you have, the same thing. Clear?
Yeah.
And NIST is also both common. This is clear?
Yes.
So this is how we are monitoring the system performance. So it should not be an injustice. Okay. So that's the reason. I'll show you some data, how this data comes. After this is the roadmap. In this roadmap, we have instrument protocol, instrument setup, sequence setup, the injection list, sequence setup, injection list, processing, and the library, and then we go for your quantification. So everything we have, we'll go one by one. For that, I'll directly go with the data. Where is our chromatogram? Okay. In this chromatogram, you can see there are multiple analytes are detected. I'll go just one by one. So once we inject the sample, we get this data. Once the data comes, you have to read this data. What is this? See, this is the masses of your component. What is this mass? We'll have to just process with the data. Library search report. If I go to library, it will show what is this compound is, naphthalene. Okay? On what basis? Here you can see there are multiple library. See here, the masses, this is our injection, this is our library injection. So masses, the same masses we have 128, 128, 129, 129, 127, 126, 126. Okay? Similarly, matching. It's a mirror image matching. Once you go with the naphthalene, if you ask naphthalene, this is your NIST library, let's go with naphthalene. Okay, so this is your naphthalene. Here you can see the structure of the naphthalene. naphthalene, molecular formula, molecular weight, exact molecular weight, probable, synonyms, and the mass structure. So 128, 128. These are some of the other masses. Same.